Alright, what we're going to focus on now is sheet metal functionality within Autodesk Inventor. Autodesk's Inventor sheet metal functionality has come a long way since its beginning stages. Inventor sheet metal capabilities are extremely competitive against products like SolidWorks, Pro Engineer, Solid Edge, these different three-dimensional tools on the market. Inventor's sheet metal functionality now surpasses some of the abilities that we have in those other tools, including tools like SolidWorks. So what we're going to do here is we're going to go ahead and start to work with the sheet metal functionality within Autodesk Inventor on this component that surrounds the dishwasher base. And so we're going to go ahead and build up some of this different sheet metal geometry. Very easily we're able to do things like generate flanges and hem geometry around our existing three-dimensional models that we're working with. We're also working with this functionality in an unfolded state. So we have the capabilities of folding and unfolding this component while working on the actual geometry that we're building within Autodesk Inventor. So we have the capabilities of unfolding the geometry and building on different sketch geometry to control how we want the model to be generated. So in this case, our goal here is to generate some cuts on the different hem geometry that we've just built up. And so we want to go ahead and lay out, using some of our sketch tools within Autodesk Inventor, some of these different cutout shapes, these customized cutout shapes that we want for this model. Now keep in mind, the only way that we have the capability of doing this is with our unfold and refold commands within Autodesk Inventor. If we didn't have the unfold and refold commands, it would be impossible to build these sheet metal shapes. The unfold refold command in this case allows us to unfold the geometry, generate the flanges and hem geometry that we've just built out, cut out the shapes, and then refold all the geometry. If we didn't have the unfold refold command, it would be impossible to generate these different flanges and hem constraints on the model. So we want to be able to generate this exact shape and distribute this through the model. This not only makes it possible, but it makes it very easy within the interface to be able to generate these different types of geometry. Notice as I'm sketching, I build these different constraints from one line to another line, perpendicular constraints, parallel constraints to this model. Once I've generated these different customized pieces of sketch geometry, I'm now just going to simply select the different areas that I want to cut out from these hems. So I'm going to use my sheet metal cut tool, tell it to cut all the way through the geometry. And now I simply have to put the geometry back together, or refold the geometry to its proper location, making it very easy to customize my sheet metal components to exact shapes and constraints that I need to generate my overall sheet metal styles that I'm working with. So I'm going to go ahead and use my refold command here, and I'm going to select the bend areas that I want to go ahead and refold and put this back in place. Makes it possible for us to generate the rips and bends according to some of the default sheet metal characteristics within Inventor. Now, unlike some of our competitors' tools like SolidWorks, we want to go ahead and make use of the sheet metal geometry within Autodesk Inventor from somewhat of a novice standpoint. Not every engineer that is designing sheet metal components today understands the rules and situations that need to be followed within building sheet metal components. But we have the capability of storing these rules in a default location so that everyone on the network can follow a specific set of gauge tables or rules when building sheet metal geometry. So this makes it very easy for an engineer not used to building sheet metal components to save time and money when generating sheet metal components, to ensure that he's following those rules and procedures. Here we're going to go ahead and generate these cutouts on the sheet metal component all the way through the geometry here, allowing us, even after the bends are created, to generate these different respective cutouts on the model. And we'll go ahead and take this component and let's open this up just to get a better understanding of what we've just generated. So we've generated some very complex sheet metal geometry, but not only have we generated, but we have the capability of flat patterning this geometry so that we can send this to a plasma cutting machine laser cutter to cut out this geometry. We can take the geometry without even creating a drawing, something SolidWorks couldn't even touch, and generate a DWG or DXF and save this directly to the machine. No drawing necessary. The capabilities of sending off directly these DWGs or DXF files to those machines and controlling how the information is being exported. So not only are we setting the information out, but we're controlling the tolerance on spline geometry, telling it to place it in the positive quadrant so that everything is lined up like we want it to be for a plasma cutting table. And also we have capabilities of viewing the different bend lines and generating, if we want, a bend order annotation table within the model itself. So Inventor's sheet metal capabilities far surpass our competition.